Hello, boys and girls. It is time to go over the Probability and Statistics Review Guide. If you follow the directions, you already solved this and you're going over it. I'm going to not go super fast because I want to explain each problem for people who don't understand. And remember that for full credit in the end, you need to turn in your work and everything needs to be corrected. If you made a mistake, please leave it on there. I want to see what your mistakes were and so that you can see what your mistakes are too. All right, here we go. Let's see. You have a bag full of square number tiles marked 1 through 16. You reach in and pull out one tile. Giving your answer in fraction form, what is the probability that you pull out an odd number? Well, 1 through 16, that's 16. So my total is 16. And half of them are going to be odd and half are going to be even. So it's 8 out of 16, but you're just going to put 1/2, right? Because half are odd. Number 2, you pull out a number divisible by 4. Now there's an inference here. They're having you infer, or I am, but other people ask these questions, that you know divisible by 4 means giving you a whole number answer, because every number is divisible by 4. You're just cutting into fourths. So which of the numbers are divisible by 4 out of 1 through 16? Well, it's 4, 8, 12, and 16. So 4 numbers out of the 16, so 1/4 of them, right? Number 3, you pull out a number greater than 9. So that's 10 through 16. 10, 11, 12, 13, 14, 15, and 16. 3, 6, 7, right? So I just subtracted 9 from 16. So 7 out of 16. Can't simplify that. Moving right along, you have a bag of marbles containing 6 red, 12 blue, 7 green, and 5 yellow marbles. You take 2 marbles out one at a time and replace them. Giving your answer in fraction form, what is the probability that you grab 2 yellow marbles? So since I'm replacing them, that's with replacement, that means there's always the same number of marbles in the end. Let's figure out how many marbles there are. 6 and 12 make 18. 18 plus 7 is 25, plus 5 more makes 30. So 30 is going to be my denominator of everything. So a yellow marble, there are 5 yellow marbles. So that's just 2 of those. Now if you multiplied and got 25 over 900, you are correct. For simplification, you could just see, well, the 5 and the 30 simplifies down to 1/6, right? Because 6 times 5 is 30. So that means your simplified fraction should be 1 over 36. You don't grab a blue marble either time. There are 12 blue marbles, so if I take 12 blue marbles out of the 30, it leaves me with 18 marbles are not blue out of the 30. Since we're replacing them, the fraction stays the same both times. 18 times 18, what is that? I'm forgetting. It's like, I should know this. 324, I did know that. I doubted myself. Never do it. 30 times 30 is 900. Of course, if I simplify this down, dividing each by 6, I get 3 over 5. And 3/5 times 3/5 would be 9 over 25. That is my simplified fraction. If you have that, though, you're fine. Number 6, you grab a red marble, then a yellow marble. There are 6 red out of 30. A yellow marble, there's 5 of them. So I get 30 out of 900. And if I do 6 times 5 is 30, well, 30 over 30 is 1, so this just simplifies down to 1 over 30. Let's see, you could not see that last one, darn it. All right, so there it is. 6 over 30 times 5 over 30 is 30 over 900. Apologize for that. 6 times 5 is 30, 30 over 30 is 1, so it's just 1 over 30. My apologies. Gotta find out. Remember where this thing is cut off. I'm used to being able to see the whole page, but I think this view you can see better. All right, and last chunk on this page. You have a bag of marbles containing 6 sparkle, 8 swirl, and 5 cat eye marbles. 7 and 8 is 15, plus 5 is 20. That's my total. You take 2 marbles, one at a time, without replacement of the first marble. Okay, so that means I go down to 19 on the second pick every time. Given your answer in fraction form, what is the probability that you pick a swirl then a sparkle? There are 8 swirls out of the 20. Times. Second pick is a sparkle. There's 7 of them. And 20 goes down by 1 to 19. 7 and 8 multiply together, make 56. And 20 times 19 is 380. This simplifies down by, divided by fourths, you get 2 over 5. So that'd be 14 over, what is that? 50 plus 45, 95. 14 over 95 is your simplified fraction. Of course, you got that. You're great. Number 8, pick 2 cat eye marbles. There's 5 cat eye marbles, so 5 over 20. That's my total. On the second fraction, it drops down to 19 marbles total, but since I'm picking another cat's eye, there's only 4 left. So that's going to give me 5 times 4 is 20, and then over 380 again. Now, if you do think kind of like I did back here on number 6, 5 times 4 is 20, and there's a 20 right there, so that's 1, so it's 1 over 19 for your simplified fraction. Okay, number 9, you don't pick swirl marble either time. So there's 8 swirl, that means there's 12 non-swirl marbles out of the 20. And on the second pick, there's going to be 1 less non-swirl and 1 less marble. 12 times 11, that's 132, over 380 again. Divide this by 4, it's 3 over 5, so 33 over 95 is your simplified fraction. Number 10, you pick a sparkle, then a sun marble. There are 7 sparkles, and then there are no suns, so 7 over 20 times an impossible thing. Can't do it. All right, here we go. Next page. Using the fundamental accounting principle, find the total number of outcomes for number 11 and 12. And we're talking about milkshakes. There are 3 sizes, small, medium, and large, and flavors are vanilla, chocolate, strawberry, and caramel. Or do you say caramel? So that's 3 sizes, and 1, 2, 3, 4 flavors. Ooh, 3 times 4 is 12. That was a tough one. Number 12, genre. For movies, action, animated, comedy, family, horror, romantic, sci-fi. 1, 2, 3, 4, 5, 6, 7. Places to watch, theater or on television. So 2 times 7 is 14. Number 13. There are 104 cookies in a jar. Even though they all look and smell the same, 3/8 of the cookies are gross. What is the likelihood you will pick a yummy cookie? Well, if 3/8 of the cookies are gross, it's 3/8 of 104. So divide by the bottom, multiply by the top. 104 divided by 8, what is that going to be? It goes in once, leaving you a 24th of 13. Yeah, 13 times 3. 39 gross cookies. And oh, I could have done this way easier. I'm thinking I asked for the number of cookies. There's 39 gross cookies, which means there's going to be 65 yummy cookies. But I didn't need to do 65 out of 104. I could have just said 5 over 8. There's 5/8 of a chance you get a yummy cookie. Here we go. Number 14. You roll a 6-sided die and flip a coin at the same time. What is the probability of getting 4 on the die and heads on the coin? Well, if it's a 6-sided die, there's a 1 in 6 chance of getting a 4. And coins are always a 50-50, so 1/2. So there's a 1 in 12 chance of that happening. Okay, here we go. Only what? 15, 16, 5 or 6 more. Here we go. Just 5 or 6 more. Hang in there. Here we go. Number 15 and 16 and 17, you're going to use a 52 card deck of playing cards to answer the question. 52 cards, 2 colors, red and black, 4 suits, spades, hearts, clubs, and diamonds, 1 of each of the 13 cards per suit, 2 through 10, jack, queen, king, and ace. Okay, what's the probability of drawing 2 jacks with replacement? Okay, well, there's 1 of each of the 13 cards, but there's 4 suits, so there's 4 jacks, right? A jack of each suit, so there's 4 out of 52. And so with replacement, it's the same each time. That's going to be 16 over whatever 52 times 52 is. 52 squared, right? It's 2704. Now, of course, I can simplify in my head here. No, this is really 4 times 13. So it's 1 over 13 times 1 over 13, and that means this simplifies down to 1 over 169. 16. What is the probability of drawing 2 clubs without replacement? Well, clubs are a suit, and there's 13 of 13 cards per suit. So 13 clubs for the first out of the 52 cards. Now on the second pick, I have 1 less club, so there's 12, and 1 less card, so it's 51. Okay. So 13 times 12, that's 144 plus 12, 156, right? And then 52 times 51 is 2652, 2,652. This simplifies down to a 4th, right? Right there. And the 4 goes into the 12, canceling that out, making it a 3. And 3 goes into 15, 17 times. Turn that off. So I have 1 over 17 for the answer, simplified. Okay, last couple problems. Here we go. Number 17, what is the probability of drawing the King of Hearts and an 8? Well, there's only 1 King of Hearts out of the 52 cards. And an 8, there's 4 of them out of the 50. Oh. I see a problem with this. I didn't state whether it was with replacement or without. My bad. So 52 if you did with replacement. Let's do that one first. That's going to be 4 over 2704. That's going to be, just divide 2704 by 4. 2704 divided by 4. Man, I proofread this twice too. So it's 1 over 676. If you did without replacement, well, I'm actually going to tell you, oh, I just realized this is in the future, so I'm going to have you correct this on the, before you take it. So this is what I actually was looking for. I was looking for the without replacement, but that's what would happen with replacement. So 1 out of 52 times 4 out of 51, that's all. That's going to be 4 over 2652. And 4 goes into 52 13 times, so it's going to be 1, and whatever 13 times 51 is, 13 times 51 is 663. That's your simplified fraction. This is the one I was looking for. Okay. Funny. I just realized this is all in the future. You haven't done this yet. All right, here we go. Number 18, your bike lock has 4 tumbler wheels with the numbers 0 through 9 on them. Using the fundamental counting principle, how many possible combinations does the lock have? 0 through 9 is 10 digits. Goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 for the 10th one. And if there's 10 4 times, well, that's 100, 1,000, 10,000. Okay. Last 3 questions. Use the following data set for problems 18 through 20. Here's my data set. I need to find the mean, median, and mode. Okay, first thing I notice is this is in not the right order. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 cards. 13 numbers. Let's put them in the right order. 7's my smallest one, right? So 7. Is there a 10 or only an 11? 11. Do I have 12s? There's a 12 and there's a 12. So 2 12s. There's a 13. Just one of them. Do I have a 14? No. 15 is here. There's a 16. No others, right? There's a 17. Do I have an 18? Yes. 19. 20? Nope, just 21 and 22. Wait. I just said 19 and wrote an 18. Oof. That would have screwed me up. There was an 18 though, yes. So 18, then 19, no 20. We have a 21 and a 22. All right, so find the mean. I've got to add all this stuff up. Ew. That's 18, 7, and 11, right? 18, 12 and 12 make 24, so plus 24. 13 and 15 make 28, plus 28. 16 and 17 make what? 33. And then 19 and 21, well, they make 40, so that's 62. So there's 165 is my total. And divide that by the 13 there is, number-wise. Ew, that's ugly. So for the mean, let's just take it to, oh, oops, put it on the calculator. Since that 9 is going to make that a 7, all this stuff is kind of irrelevant. So 12.7 would be an extremely acceptable one. The median is in the middle. There's 13 numbers, so 6 on each side. 3, 4, 5, 6. Here's my median. It's 16. And my mode is the only repeated number, which was 12. All right, this one's an easy one. Find the minimum, maximum, and range. Minimum would be 7, right? Maximum was 22. The range is 22 minus, I didn't label these, what a lazy person I'm becoming, sorry. And 22 minus 7 is 15, so my range is 15. That was fun. Okay. Find the lower quartile, upper quartile, and interquartile range. Okay, I already found the median. This is the box and whisker plot questions, right? So remember, when I'm finding the lower quartile, I'm finding the middle of these. And the middle's right here between 12 and 12, which is 12. So my lower quartile is 12. My upper quartile is between, oh, wait a second. Did I? 1, 2, 3, 4, 5, 6, 7. I forgot 25. Oh, my Lord. Kids, why didn't you say something to me? So that means the median is still 16. The mode is still 12. The median has changed, hasn't it? Dang it. This whole problem's wrong, too. Ugh, dum-dum. The min is still 7. But the max is now 25. 25 minus 7 is 18. There's the range. Let's find that mean real quick. Well, I said it was 165 right here. So add 25 to 165, I get 190. So 190, right, divided by 13. Dang bad. I said 13 because I wanted to remember to count them. I didn't do it right. So this is 14.6. If you want to do 14.62, either one's kind of fine. All right, back to number 20. Here we go. I've got the lower quartile already. I'm up in the upper. It's between the cutting in half between the third and the fourth number, so 19 and 21. So I can add 19 and 21 and say that's 40 divided by 2 is 20, or I can know that the number between 19 and 21 is 20. So the interquartile range is the upper quartile minus the lower quartile, which is 20 minus 12 is 8. And there you go. You can't see that last part at all. Sorry. I hope you got most of these right. Make sure to correct anything that you got wrong. Please, we all make mistakes, but fix it. I think I'm all right. If you catch anything, of course, please let me know. And this is a lot like your test, so I think you're ready for it. All right, kids, take care.